Hi, our lesson now is about Voronoi diagrams. Let's first understand what's meant by Voronoi diagrams. A Voronoi diagram is like this map. I have different sites. Let's say this is site A, this is site B, this is site C, this is D, E, F, G, and H. The Voronoi diagrams say that any point inside this area is closer to H than any other site. Also, if I have this area here bounded by B, it means that any point I find inside this area is closer to the site B than any other site outside. So our role in Voronoi diagrams is to create the boundaries for which I will consider any area to be closer to which site than the another. This is the main importance of Voronoi diagram. Voronoi diagrams have many applications in our real life, as the waste dumping problem is like if I have waste, which is the closest site I will be dumping there. Another Voronoi diagram is already shaded, is this Voronoi diagram. You can see clearly that the area in the orange at any point here in the orange area is closer to this site than any other site. Another application on Voronoi diagrams is sometimes if you want to go to the supermarket and you live in a specific area. Because of the application of Voronoi diagrams, you'll be capable of going to the closest supermarket which is close to you. Let's now have an example to show clearly how we can draw Voronoi diagrams. In this example, we want to draw a Voronoi diagram for points A, B, and C. So now we have to segment the areas to show clearly where is the area by which all the points are closer to A, closer to B, or closer to C. How do we construct Voronoi diagram? The first thing I have to do is I have to draw straight lines connecting the points A, B, and C. So I have to draw a straight line connecting from C to B. I want to draw another straight line connecting A and B. Also, I have to draw another straight line connecting A and C. After drawing my straight lines, I want to draw the perpendicular bisector for each line. We have to draw the perpendicular bisector for each line. To find out the perpendicular bisector, the first thing I have to find the gradient of the perpendicular line, which is I need to flip the gradient and I change the sign. And I need to find the coordinates of the midpoint so that the perpendicular bisector must pass through the coordinates of the midpoint, because my perpendicular bisector must pass through the midpoint. Now, Let's assume I have the midpoint between A and B to be at the point which is 3.5, which is somewhere here. This is, and between C and B it's there, and A and C it's somewhere in here. I have to draw the perpendicular bisector for each line. Let's start by the points A and B. The perpendicular bisector would be this line. I have to move it slightly to the left. And the perpendicular bisector between A and C is this line. Also, I want to draw the perpendicular bisector between B and C. I'll draw it in green color this time. So this is the perpendicular bisector between A and C. After that, I will be checking the areas that are closer to A than B or C, and then checking the areas that are closer to B than C or A, and so on. So now, let's check the point A. Where are the areas closer to A than C? It is the area above this perpendicular bisector. So I will be shading the whole area in this yellow. And also, where are the areas that are closer to A than B? It's to the left side of the red line, which is the perpendicular bisector between these 2 points. So the area shaded in yellow is where I'm having all the points closer to site A than any other point. I will repeat the same thing for site B and site C. So now, for site B, where are the area which is closer to B than C? It is here. Also, where is the area that is closer to B than A? It is to the right of the red line. So the area shaded in the blue color is the area closer to B than any other site. And the left area is for the site C, so I'll be having the site C shaded this way. I'll have it to be in pink. So all to the right is closer to C than to A. Also this side. So by this, I created a Voronoi diagram stating clearly the areas which are closer to A, to C, and to B.